Hello guys, my name is Balkrishna Srivastav and welcome to CodeWithBK. So in this video, we solve the problem to insert node at the end of the linked list, and this will be handy in your Computer Science 2023 theory paper preparation. So before we begin, it is a humble request that if you like this video, please subscribe to my channel because it is your subscription that is going to help me grow on YouTube. Alright, so we are given a class node that has an integer num and node next. This basically makes a node of a linked list. This is the method that we need to complete. Void insert node. It has a node start pointer and int n. So this is basically head. So you can have head or start pointer, okay? And you need to complete this method so that a new node with a value n comes at the end of the linked list. So let's take an example. So if I have a linked list, I hope this is visible because this marker is brand new, but it is very light. I don't know why shopkeepers do this. Anyways, so 10, 5, 8, 6, 2. We have 5 nodes. The last node has its next value as null. This is what defines a list. And then we have start pointer pointing to the first node in the linked list. So the start pointer is very crucial because this defines the starting point of the linked list, okay? And basically the nodes continue as long as they are not null, okay? This is what a linked list is. And we have an integer data here. So this is the int value and this arrow is the link to the next, okay? And you can have any data type here. You can have any kind of data here. In this case, it is an integer. You can have a character, double, float, or maybe a non-primitive type as well, but they won't go that complicated. You will probably hit a primitive data type here, which is integer, char, or float, or maybe a double, okay, or maybe a string, okay? So what exactly do we mean by inserting a node at the end of the linked list? So I want to create a node and I've been given a value n. So I'll say this is my new node with a value n and the next of this is null. Okay. So step A is create new node. Okay. All right. This has to come at the next of the last node. So you say the next of last node is pointing to this node. Okay. So this is your step B. Okay, they have to connect the last nodes next to this new node. Okay, and head remains the same. It does not change. It stays where it was. So I'm taking care of this start pointer, which is the head of the linked list, because this is what defines the linked list. This defines the first node, and this is very important. So we need to code these two steps in a solution. Okay, the first one is create new node. Okay, so we do node new node. The name of my new node is equals to new, using this new keyword, okay? And when I'm creating this object, I call the default constructor because there is no constructor defined in this class. So I use a default constructor. And int and node, okay, both these types do not have access modifiers here. It means you can directly access them outside the class using the name of the object. So if I want to set num in this object, I can simply say new node dot num is this new value and new node dot next is null. Okay, so my part A is complete. Okay, so let me redraw this. Okay, so this was pointing to null and we cross this and we use this. Then we need to set the next of the last node to this new node. But how do we know the last node? We just have the start pointer. So we have to traverse the list starting from the head, from the start pointer, reach the last node and then connect this to this last node. Okay, so now our task is to basically reach the last node. So how do we reach the last node? So I take a pointer, okay, I take a node current, okay, which is pointing to this node. Okay, this is basically saying current is equals to start PTR. I'll say CURR. So my current is pointing to this first node and I want my current to reach the current last node. So this is not yet connected. Okay, this connection is not yet made. This connection is still to be made. Okay, till null. Okay, I'll disconnect this. Okay, let's see. Okay, only this part is done. B part is basically set next of last to new node. Okay, this B part is to be done. So I want current to reach last so that I can set next of last to this new node. Okay, how do I reach my last? So I take current forward as long as the next of current is not null. Okay, because what differentiates all these nodes from the last node is that the next of this last node is null. and that is where I stop. So my condition current dot next equal to null will basically tell me that I'm at the last node. Okay, so I need to go on traversing this list as long as currents next is not null. So my while loop condition is going to be, so current starts at, I take node, current starts at start pointer. Okay, and this current goes forward as long as this is true. So I say while current dot next is not equal to null, I do current is equal to current dot next. So let me explain this. Current is at start pointer, okay? While this is true, we do this. Current dot next is this. This is not null, true, okay? You execute this, current is current dot next. Current dot next is this. Current now points here, okay? You go back to check for the while loop condition. Current dot next is not equal to null. Current dot next is this, not null, okay? You do this again. Current is current dot next. Current moves here, okay? Again you check this, current dot next is this, not null, true. Current is current dot next, current now moves here, okay? You check this again, current dot next is not null, current dot next is this. You do current is current dot next, current now moves here. Current dot next not equal to null is false for this last node, okay? This is the last node, so this loop breaks. So when the loop ends, okay, current is at last node, okay? Then we do this B part, that we connect this as next of last node. So we do current dot next is new node, okay? And now it points to this, okay? So this is our part, okay? All right. So when we reach here, we have added a new node with an integer value n at the last of this linked list. Start pointer remains where it was. So you see, we have not changed start pointer anywhere, okay? You could also use start pointer to traverse this list, but if you make start pointer reach here and you haven't saved start pointer value anywhere, you lose the head. Once you lose the head, you lose the list, okay? That's why keeping start pointer at the head is always important. Whenever you want to traverse the list, copy start pointer into another variable like I did here, okay? And then use this variable to traverse, okay? Always keep start pointer at the head, okay? Okay, so one last thing I want to point out is in the requirements they usually say, I mean in all the previous various question papers, they say that this is an existing linked list. That is, there is at least one node in this linked list, that is, this linked list is not empty. If this linked list is empty, so my start pointer value will be null, okay? It means it is not pointing to any list right now. So if you want to handle this case, even though it will not be given, you can add an if else condition. So if start pointer is null, okay, adding to the front, middle and the last will all be the same because you are adding the first node. So when you add the first node, okay, to an empty linked list, it will look something like this, okay? So we can add an if condition. If start pointer is null, I set new node to start pointer. So we can do something like this. If start ptr is null, okay, I said new node, start pointer to new node, right? I said start ptr to new node, okay, because my new node is the value n for the data and next to null, okay, and my start pointer should point to it, okay? Else I do this exact thing. I move to the last, I set the next of the last two node, okay? I'll do it in the code. When I run this on the system, I'll show you how this is done, okay? So if you like this video, if you found it helpful, please do subscribe to my channel because your subscription is going to really help me out, okay? Let's move on to running this code on the system now. So this is the node class that was given to us, and this is the insert node function that we wrote, okay? Creating a new node and then setting the next of the last node to this new node. So in my main, I've created 5 nodes. I have linked them so that it becomes 10, 5, 8, 6, 2 null, okay? So let me just print this. So I get 10, 5, 8, 6, 2 null. So to add a node at last, I call this insert node. I say functions dot insert node, say I want to add the value 100. So it should be this with 100 at the last, okay? So this dash and this arrow, they basically mean the same thing. So let me print this again, okay? and you will see there is 100 added. Okay. So for your ICSC paper, this is what you need when you have to insert a node at the end of the linked list. But this function as a whole is not entirely correct because we are not handling the case for the start pointer as null, and we are also not returning the updated head. Okay, because if start pointer is null, we would want to return the updated head. But this is going to work for your ICSC paper. So this is it. And I hope this was helpful. So please do like this video, subscribe to my channel, and please let me know in the comments if there was anything that was not clear to you in this video, if there's a question you want me to solve, or if there's a concept you want to discuss. Thank you.